The incredible speed and unexpected brightening of 3I/Atlas have left scientists grappling with the possibility that this interstellar object might not be what it seems. As it hurtles through our solar system at an astonishing 130,000 miles per hour, its behavior defies conventional cometary physics. The object's green-tinged coma, rich in CO2, and its rare sunward antitail are unlike anything observed before, prompting wild speculation about whether 3I/Atlas is a natural comet or a carefully engineered probe from an advanced extraterrestrial civilization. If you're still watching, subscribe now. You crave more than answers. You seek what lies beyond. Subscribe now and be part of the few who never stop searching. With its trajectory and characteristics presenting anomalies that challenge our understanding of space physics, it raises profound questions about what might be lurking beyond the stars, and whether we are witnessing the first signs of an interstellar visitor with a far more intelligent origin. Despite the absence of direct evidence pointing to artificial propulsion, the improbability of Atlas's journey has left some to ponder the unthinkable. Could this be an alien reconnaissance mission sent to gather data about our solar system? Its unusual chemical composition, combined with an almost perfectly calculated path through the solar system, suggests an intentional design, making its passage an event of great significance. As astronomers continue to map its trajectory and collect data using some of the most advanced telescopes available, the mystery of Atlas unfolds, sparking debate within the scientific community about whether we're witnessing a natural cosmic curiosity or something far more deliberate, and possibly alien. 3I/Atlas, an interstellar object currently racing through our solar system, is making waves in the scientific community for its bizarre characteristics and unusual behavior. Discovered relatively recently, it is traveling at an extraordinary speed of 130,000 miles per hour, and it has caught the attention of astronomers worldwide, who are trying to make sense of its every move. As this object defies much of what we know about comets, it's sparking new debates on its origins and nature, questions that might challenge the very core of our understanding of the cosmos. What makes 3I/Atlas stand out is not just its incredible velocity, but its unexpected luminosity. Over time, it has brightened in ways that suggest something more than the usual cometary activity. This sudden brightness, coupled with a strange green-tinged coma, rich in carbon dioxide, has drawn immediate attention. A typical comet's coma would be composed mostly of water vapor and dust, but Atlas's coma, mostly CO2, with minimal water, has astronomers scratching their heads. This difference in composition alone suggests that the object could be from a very different part of space than we're used to seeing. The most puzzling feature, however, might be the sunward antitail. This is a rare phenomenon observed around Atlas, and its occurrence only adds to the mystery of the object. Comets typically develop tails that point away from the sun, as particles are blasted off by the sun's heat, but an antitail, one that points toward the sun, is almost unheard of. The presence of this feature has caused many to re-examine the known physics of comet behavior. Could this anomaly be the result of something artificial? Could Atlas be an object engineered by an advanced civilization? Despite extensive observations using some of the most powerful telescopes on Earth and in space, such as those in Hawaii, Chile, and the Hubble Space Telescope, no definitive answer has emerged. All the data points to a hyperbolic orbit, meaning that Atlas is an interstellar object, and it will not remain within our solar system for long. It is passing through the system on a one-way trip, never to return. The fact that it came from outside our solar system, with a trajectory so precisely calculated, raises questions about whether this is purely natural or the result of intelligent design. As we consider what 3I/Atlas might be, the debate around its origin is growing louder. Some scientists believe that the object's unusual acceleration and high brightness are simply the result of natural forces, like solar heating. These forces could explain the outgassing of CO2 and the formation of the coma and antitail. Others, however, are not so sure. The improbable speed, trajectory and alignment of the object with Earth, Venus and Jupiter suggest that Atlas may have been intentionally directed. The idea that it could be a probe sent by an extraterrestrial civilization, designed to explore our solar system or even gather data, is being seriously considered. Could Atlas be an interstellar reconnaissance mission? The chemical composition of Atlas's coma further fuels this debate. The high concentration of CO2 and the absence of water suggest that it might have originated in a much colder region of space than what we typically see in our own solar system. If it did form in a cold, distant environment, it could indicate that Atlas comes from a planetary system unlike ours, a system with conditions that we might not fully understand. This could be a clue to the possibility of extraterrestrial life and the way comets might form in other star systems. It could also support the notion that the object is not a typical comet at all, but something far more unusual. While 3I/Atlas poses no immediate threat to Earth, its presence challenges us to rethink how we approach the detection and defense against potential threats from space. Its velocity, size, and trajectory may not bring it into direct collision with our planet, but the nature of its arrival, so precise, so carefully mapped out, raises questions about our ability to detect and possibly intercept objects in the future. With current technology, we are barely scratching the surface of what's possible in terms of planetary defense. And while 3I/Atlas won't harm us, future objects could be different. The urgency of improving our detection systems and developing interception strategies is clear. The debate over whether Atlas is a natural or artificial object has sparked much discussion, not just among scientists, but also in the broader public. Some see the object as the latest evidence that we might not be alone in the universe. The highly improbable nature of its path, there's less than a 0.005% chance of its alignment being purely by chance, suggests to some that it could be intentionally engineered. If so, it would raise significant questions about the potential for extraterrestrial civilizations, and what their intentions might be. Could there be more objects like Atlas out there, possibly on similar journeys of exploration? Are we witnessing the first signs of something much larger, an interstellar presence or effort that has been hidden from us until now? For now though, all we have are questions. We are left to analyze the data and consider the possibilities. The scientists tracking Atlas are continually gathering more information, looking for any clue that might tip the scales toward one theory or another. The James Webb Space Telescope and the Very Large Telescope are expected to play key roles in future observations, and they might help us find the answers we're looking for. But until then, we're in a race against time, trying to decode the message left by this mysterious visitor from another star system. As we wait for new observations and further breakthroughs in our understanding, one thing is clear: 3I/Atlas is not just an object of scientific interest, but a symbol of the unknown. It forces us to confront questions about the nature of our place in the universe, our ability to explore it, and our preparedness to handle whatever or whoever might be out there. The mystery of 3I/Atlas is far from solved, and as astronomers continue to study it, one thing remains certain: the object's unexpected appearance in our solar system has opened up a world of questions, and it is up to us to find the answers. This is a moment in space exploration that demands our attention, and the discoveries yet to come could reshape our understanding of what is possible in the cosmos. If you're fascinated by the mysteries of the universe, and want to stay up to date on the latest discoveries, don't forget to like, share, comment, and subscribe for more intriguing updates and in-depth discussions about the wonders of space. Your thoughts on 3I/Atlas are always welcome. Let's keep the conversation going. There's something unnerving about it. An object, older than our solar system, faster than anything we've launched, behaving in ways no known comet should. 3I/Atlas didn't drift in casually. It sliced into the solar system on a hyperbolic trajectory, meaning it came from outside and it's not staying. It's here once, one pass, no repeats. That in itself is rare, but then came the details, the ones that don't fit into any comfortable category. It started brightening, not gradually, like most comets as they approach the sun. Atlas flared up with a kind of energy that caught astronomers off guard. Telescopes watching from Hawaii and Chile picked up the light curve and realized something wasn't right. The intensity, the speed. It didn't match what a frozen body of ice and rock from deep space should be doing. It wasn't just bright, it was aggressive. Then came the color. Green, not unheard of, but strange in this concentration. The coma wasn't water-rich, it was saturated with carbon dioxide. CO2 in this volume, with so little water present, implies something chilling. Atlas formed in a place far colder than our solar system has ever known. A place where water freezes so hard it's more rock than ice, and only the most volatile materials like CO8 and CO remain capable of outgassing under distant starlight. That shifts the whole narrative. It means this isn't just a piece of cosmic debris thrown off from a passing star. It's a time capsule from a planetary system that might have never seen light like ours. Or worse, or better, depending on your point of view, it's not debris at all. It's a product, a device, something crafted, not formed. But it's the anti-tail that really cracks the surface of certainty. When astronomers noticed a tail pointing toward the sun, not away from it, the physics didn't line up. Tails form when solar radiation pushes material off a comet's nucleus, away from the sun. So how does a tail form in the opposite direction? You need incredibly precise particle distribution, specific grain sizes, and very narrow velocity ranges. It's rare, improbable, and somehow it happened here. One explanation is that the anti-tail isn't a tail at all, it's a trail, a path of material deliberately shed or jettisoned in a controlled way. That brings you back to the uncomfortable question, is this natural? Because if it's not, then it's a message in motion, a probe, a scout, a sentry. And then as if all that weren't enough, the path, the sequence, Mars, Earth, Venus, then a slingshot by Jupiter, 1, 2, 3, 4, like stepping stones laid out with precision. These aren't random flybys, these are data collection points, spaced with the efficiency of a mission plan. If it's a coincidence, it's one in millions. If it's not, then someone or something set this in motion a long time ago with purpose. Still, many cling to natural explanations. Solar heating, they say, is enough to account for the acceleration. Atlas is outgassing, pushing itself forward on jets of vapor. But even that raises eyebrows, because for a body this size, the thrust required to account for its observed speed changes is unusually high. The jets would need to be incredibly active and precisely located, something we don't often see in comets, and Atlas isn't shedding mass in the way we'd expect. No violent fragmentation, no chaotic spin, just speed, direction and brightness, like a bullet of ice lit from within. There's no sign of propulsion, they say. No engine plume, no exhaust. But do we even know what an alien propulsion system would look like? If someone built this, they're ahead of us by thousands, maybe millions of years. Expecting their tech to glow like a rocket is wishful thinking. More likely, it would be invisible to our sensors, or silent, or buried deep in the object's structure, hidden under a crust of interstellar dust. Some argue we've seen this before. SEPTA Oumuamua, the first interstellar object confirmed to pass through our system in 2017. It too had strange acceleration. It too defied easy classification, but it was silent, tumbling, without a coma. It passed quickly, left questions, and was gone. Atlas, on the other hand, is loud, bright, active. It's not trying to hide. And then comes the size. This is not a pebble. Atlas is the size of Manhattan. If it were to hit Earth, it wouldn't leave a crater. It would rewrite the surface of the planet. But it won't. Its path is clear. There's no threat here. At least, not a direct one. The real threat is what it means. If this is natural, it means our models are broken. Our understanding of comet physics is incomplete, possibly dangerously so. If it's artificial, the implications are vast. It means someone out there has reached us, not with radio, not with laser signals, but with presence, with hardware, with a visit. Either way, we're not ready. This raises another problem: detection. We barely saw it coming. Our current systems are designed to spot near-Earth asteroids, not fast-moving interstellar intruders. Atlas wasn't announced with fanfare. It was spotted, logged, and only later flagged as unusual. If it had been on a collision course, we would have had little time to react, and no way to stop it. Not at that speed, not at that scale. This isn't just about curiosity anymore, it's about capability. Atlas is a wake-up call. Whether it's a natural visitor or an engineered artifact, it exposes our blind spots, our lack of coverage, our lack of readiness, our lack of imagination. And so now the race is on. Instruments are being pointed, spectrometers are collecting data, scientists are pushing the limits of what our best telescopes can capture. The James Webb Space Telescope will soon take its turn, followed by the Very Large Telescope and others. What they find may settle some debates, or spark entirely new ones. What we do know is this: Atlas is not behaving like any comet we've seen. Its composition doesn't match local models, its path defies probability, and its features raise more questions than answers. Every new reading challenges something we thought we understood. For those holding out hope that it's artificial, there's still no smoking gun, no beacon, no maneuver, no transmission. Just a lot of improbabilities stacked together in one very fast, very strange object. But absence of evidence is not evidence of absence. The laws of physics still apply, but maybe, just maybe, not all the ones we know. This could be the first probe we've ever encountered, or the 10th, if others slip by unnoticed. Maybe they pass through all the time, quiet, fast, unseen. Maybe this one is just bright enough to notice, just active enough to spark attention, just deliberate enough to suggest intent. And maybe that's the point. Atlas isn't just passing by, it's showing us how much we still don't know about comets, about interstellar space, about our place in the galactic neighborhood. Whether it's a rock, a relic, or a reconnaissance drone, it's real, and it's here, and soon it will be gone, fading into the void, leaving behind only questions. The clock is ticking. 3I/ATLS is moving fast. Too fast for hesitation, too fast for bureaucratic science to catch up. By the time the debates are over, by the time the models are updated, it will be gone. One arc through the solar system, one streak across human history, and then nothing. Just data, just memory. And still, we don't know what we're looking at. We're seeing acceleration that doesn't quite add up. It doesn't match gravity alone. The explanations being offered, sublimation, jets, solar heating, feel more like placeholders than answers. The CO coma is real. The non-gravitational acceleration is measured. But how do you explain a course that threads key planets so cleanly? Not a near miss, not a chaotic dive, a precise sequence, as if it wanted to be seen, or needed to be here. The odds of a naturally occurring entering the solar system on that path, with that velocity, and exhibiting those features, astronomically low. Not impossible, but close. Less than 0.005% chance, by conservative estimates. And yet here it is. It's not emitting signals, it's not changing direction mid-flight, it's not broadcasting beacons or sending pulses of energy. But that doesn't mean it's inert, that doesn't mean it's not watching, that doesn't mean we aren't being observed in return. The absence of noise isn't silence. It might just be a technology we can't yet perceive. We used to think interstellar travel was a fantasy. We used to believe our solar system was isolated, self-contained. But now, in the space of just a few years, multiple objects from beyond have passed through our cosmic front yard. First came Oumuamua, now Atlas. They don't behave the same, but both defy expectations. Both broke the mold of what we thought was possible. What we're witnessing might not be an anomaly, it might be a pattern. Atlas weighs in at nearly the size of Manhattan. That's not something you dismiss. That's not something that just falls into your neighborhood without notice. And the fact that we only detected it when we did, so late in its approach, should terrify anyone paying attention. We are not prepared. If this object had been on a collision course with Earth, we would have had no time to act, no plan, no defense. At that speed, kinetic energy alone would be enough to vaporize a car. The impact would be cataclysmic, and we wouldn't have seen it coming. We need better eyes in space. More than that, we need faster reaction times. Atlas has exposed a critical weakness in our planetary defense systems, not because it's a threat, but because it could have been. And even now, even knowing all of this, we're still not sure what it is. Some insist it's a comet, just a strange one, from a colder system, maybe, or formed around a different kind of star. But others look at the data and see intention. They see patterns, they see design. You can't dismiss the implications just because they're uncomfortable. Because if 3I/ATLS is artificial, then the universe just got a lot smaller, and a lot more crowded. It would mean that somewhere out there, intelligent life exists. Not in theory, not in speculation, but in action. Someone, or something launched this someone built it, someone plotted its course, maybe to observe, maybe to explore, maybe for reasons we'll never understand. And if Atlas is natural, that's still not a consolation. Because it means our knowledge of astrophysics is deeply incomplete. It means interstellar bodies can behave in ways we didn't predict, and we're only now beginning to catch up. It means our models, our simulations, our assumptions, all need to be revisited. Either way, we're standing at the edge of a new frontier. We don't get to choose the timing. We don't get to prepare on our schedule. The universe doesn't wait for us to be ready. Atlas is a reminder of that. What we do next matters. The telescopes aimed at Atlas, the James Webb, the Very Large Telescope, and others, might be our last chance to capture high-resolution data before it leaves us forever. Every spectrum, every image, every data point is a clue, a chance to solve a mystery that stretches across light years and epochs. Because once it's gone, that's it. It will sail past Jupiter, slingshot into deep space, and vanish into the black, out of reach, out of sight. Just like that, we may never know for certain what it was, but we'll remember that it came. A flash of motion through the void, a silent messenger, whether sent by accident or design, a reminder that the cosmos is not a quiet place, that we are not alone in its gaze. There's no final answer yet, only questions, and that may be the most important part of this story, because those questions, the ones that keep scientists awake, the ones that challenge everything we thought we knew, they're the ones that move us forward. Atlas is doing more than just flying through our skies. It's pointing outward, beyond, past the borders of what we thought we understood. It's forcing us to look up again, to wonder, to prepare, and to listen. If you've been following the story of 3I/ATS and you're as captivated by its implications as we are, don't just watch from the sideline. Like this video, share it with others who need to know what's unfolding above us, and leave a comment with your thoughts. Is Atlas a natural visitor or something more? And make sure you're subscribed, because this story isn't over. The cosmos doesn't wait, and neither should we.